All right, so here is some questions that Professor Steinberg supplied for us to go over. So we're just gonna fill these out, and then he also said to go over some recursion problems, writing recursive methods. So we're gonna do that as well after we finish this, and then answer any questions you guys have while we're doing this, and at the end as well. So I'll just start. So consider the following method. What is returned by calling the method with parameters 5 and 10? So 5 and 10. Well, let's just plug it in. So we call it initially with 5 and 10. Let me just, I'll work on this side. So calling, I'll just write function 510 for now. We're entering inside x is plus plus, so x equals 6. If x is equal y, 6 is not equal 10, so then now we return f of y divided by 2. So y divided by 2 is 5, and x, which is 6. Now we do x plus plus, so x equals 6. Now we have x does equal y, so now we return x. So this becomes, returns x, and so this function then returns x as well, which is 6. So that's the answer for question one. For question two, well, I'll just add any questions for this part. Just give it one sec. Okay, we're all good. Uh, so mystery, now we're calling mystery 1, 7, and then this guy over here, we'll do the same thing. So once again, is just a shortcut for mystery. So we're calling it with 1, 7, and this A, B, C, D, E, C, C, B. So is B less than A? 7 is not less than A, so we don't do anything. Char at A. Let's just do char at A. I'll just write that. So char at A is 1, char is B, and then char at B is 7. So let's just 0, 1, 2. That's B. It does equal. So now we return uh, 1 plus the function A plus 1, B minus 1, and then the same character, the same string. So now when we call this function, uh, is B less than A? 6, no. So now we have, I'll just do, oh, I gotta slow down. Okay, okay. Sorry. Um, okay, so now we're doing char out of A. A is 2. So, let's see, 0, 1, 2. Char out of A, which is 2. That is C. Char B, which is 6, which is C. So they are equal. So now we return 1 plus, just get rid of this, a plus 1, which is 3, b minus 1, which is 5, and then the same string. And then I'll just put this over here with the indexes so it's easier. Okay. So now we're going into this function call. So C, once again, is B less than A. We have 5 and 3. 5 is not less than 3. So now we're into here. Char of A. A is 3, which is D. Char of B. Index is 5, which is C. Now, does D equal C? It does not. So now we return this part. So C return mystery. A plus 1, B minus 1, A plus 1, 3 plus 1 is 4. B minus 1, that's 4. And then the same string. Okay, so now we're into calling the function again. Is B less than A? Is 4 less than 4? It is not. So now we proceed with this if statement. And so B is equal to 4. So they're gonna be both the same character, which is E. So CA and CB is equal to E. They are equal. So we run this. So you return 1 plus A plus 1, 5, B minus 1, which is 3, and then this string again. And of course, that doesn't matter because once we enter this function, now this if statement is true because 3 is less than 5. Remember, this is our A and this is our B. So we return 0. So this guy returns 0. So now just move this. That's blue. So this returns 0. So this equals 1 plus 0, which is just 1. And now we return, this goes back up. This whole thing is this guy. So this whole thing returns 1, this value. And this guy returns from here. So this is 1 plus 1, which is 2. And this guy returns from here. This is 1 plus 2, which is 3. And then this whole thing is the result. So the final answer is 3. So we basically did this. We went down the recursive call, we found our base case, and then we basically went back up. Is everyone good with this so far? Any questions?
Um, I think these two examples and looking at the linked list ones that are coming up on the next page, um, he did go over all of these in class. So are these the right questions? I'm just curious.
Yeah, so when we were trying to reach out to him, he basically told us that let me try to find it. This is what he gave us, and to make similar qu type of questions. Um, I don't have any similar questions. I do have some questions from Professor Akinlar, some recursive questions, so we can try those. I mean, those are a bit, I'd say, far harder, but we can try them. So let me just pull it up. So if you guys went over all this, then we can move on to something a little different.
Yeah, thank you.
Yep. Okay, so these are some recursive practice problems. So I think recursion is probably the main thing he wants to focus on, Professor. Uh, so we're just going to go over writing recursive functions. Let me see. Digits from the list. Okay, just trying to pick some because low keys would probably take me quite a few minutes to think about it. So let me just try and find one that's decently easy slash hard. It's one. Okay, we could try this one. So zoom in. Basically, let's see, let's read it. Write a recursive function called digit match. The function has three integer parameters, um, first, second, and third, which are all positive and have the same number of digits. It returns the number of positions where the digits match. Uh, so let's see, for this number example, we have 777. That does not match. We have 666. It does match. So it counters one. Then we have 7, 5, and 1. They don't match. So it returns 1. For the second example, the first digit matches, the second digit matches, but the third does not. So there's a total of two matching digits. So I basically need to create a function that returns the matching digits. So how can we do that? Let's see. Thinking if it's better to just code it because I don't really want to handwrite that. Uh, let's try that.
Um, I'm thinking if it takes in like XYZ, it would um it would try like X mod 10 equals Y mod 10 And if y mod 10 equals z mod 10, then return 1 plus digit match x over 10, y over 10, z over 10.
Yeah, that's pretty much it. But and what if the digits don't match?
If they don't match, then just uh, don't do 1 plus the recursion, just do the recursion. And then for the base case, if the numbers divided by 10 equals 0, that means then we've hit the end of it. So then return 0, right? Does that make sense?
Yeah, and that makes sense. That makes sense. I guess I'll just quickly cut it up so everyone else is cool with it. Let's see. So in a recursive function, there's always a base case. So let me just write the skeleton. So the recursive function, we need a base case. So we can see here that when we have the numbers 168, 567, 767, we're going to check the first digit, and then we're going to cut it off. We're going to check the second digit, cut it off, and then we're left with these three digits. And then once we cut them off, we're left with what is essentially zero. So our base case can be this. Because remember, when we're cutting off a digit, in order to cut a digit off, we just divide by 10. So when we have one digit and divide by 10, that'll equal to zero. So now for the recursive call, we can simply get the first digit. To get this, you just do mod 10. So we can check if the first digit of all numbers is equal to each other, and then return 1 plus. And if they're not equal, we simply return this. And a quick test. Do 2. Let me just 1 and 2. So yeah. So is the answer for this question. Very good. So clearly this is maybe a little too easy. Let's see. Let's try to find any questions. Oh wait, any questions for this question? Try to bump things up then. Okay, let's see. The number of positions where one number has an even digit and the other has an odd one. The function knows by this, it would turn 2 because the third and the fourth. So, okay. Okay. So this, we're returning, basically we're taking each digit on both numbers. If one is even and the other is odd, we add one to the count. And we're doing that for every digit. So we're basically counting the number of digits that are opposites. Does anyone have any ideas on how to complete this? And so let's see. We're gonna do the same uh, process. First, we're gonna do our divide 10 process to get to cut the last digit. So this removes the last digit, and then mod 10 to get the last digit. So we're given two numbers. We want to go digit by digit. So we're going to do some mod 10, some comparison, and then divide 10, and it repeats. So we also need a base case as well. Um, the base case will be the same as the previous question. So if x equals 0, because when we're removing the last digit, if it's just one digit, divided by 10, it'll equal 0. So we can do if a equals 0, just return 0. And now we want to do some check if the last digit. So just do this. So those are our last digits. We want to check if they're both even or both odd. To do that, we can we know how to check if a number is even. We do mod 2. So if mod 2 if last A mod 2 is equal to last B mod 2, then they're either both even, 0, 0, or both odd, 1, 1. So in that case, we return the last digit cut off on both numbers. If they are different, so one is even, the other is odd, then we return 1 plus digits opposite. Then let's see if that's right. 2 and 5. Any questions on this question? Is that an easier way of writing if first mod 2 equals 1 and second mod 2 equals 0? Yeah. So we have one question saying instead of doing this, we can do this. So yeah, this is basically the same, these conditions. Um, whoops. In fact,
What's the opposite?
we actually don't even need the mod 10, actually. So yeah, these are basically the same conditions. This is just shorter. Because let's say this is this means that it's odd, this is even, or this is even, and this is odd. In this case, if a mod 2 is equal to b mod 2, then they're both even, or they're both odd.
Wait, wouldn't it be A mod 2 equals 1, B mod 2 equals 1, and then A mod 2 equals 0, B mod 2 equals 0?
Yeah. Yeah, so they have to be both be equal. Or instead we could just do like this instead.
In that if block, can we do if a mod 2 is equal to b mod 2 and then keep the one on the outside on the other return?
Yes. So this way right here is same as just doing what we did before.
Yeah. Yeah.
Yeah. This is just shorter. Just double check that. Yeah. So these are different. So we return one plus. Yep. Okay. Let's try to find a more challenging question that hopefully I can do.
Could we get these questions like in a PDF or something?
Yes. I'm not sure if I can upload it on Zoom.
Yeah,
It
we
doesn't.
can, you can click on file, it allows you on in the chat.
Okay, let me see. Oh, I can't click your computer. It's grayed out. Uh, hmm.
It doesn't, what happened? It doesn't let?
Yeah, like I click file and then when I try to click your computer, it's grayed out.
Oh, uh,
Let's see. Wait, is it because I'm not the host? Oh, wait. Got it. Okay, let's see. Oh, I just sent it this. Let me try that again. Here you go. Let's post in the chat.
Thank you very much.
Yeah, no problem. And yeah. So let's try to find a problem. Swap first. Swap the first digits of the two positive integers. Yes. Oh, so okay, I think this has to deal with like some pointer stuff. Let's see this one then. Okay, more pointer stuff. Recursive function call start with. Return the function has two integer parameters. It determines whether the second number starts with the first number. For example, this number starts with this and with this, but does not start with 197. If the second number starts with the first number. I see, okay. Any ideas, boys and girls? Hmm. So if the second number starts with the first number, we need to somehow remove turn this guy into the same. Actually, we just turn it and check if they're equal. I believe. So let's get a more complicated example. We have 196. So we're given these two numbers. We can check, are they equal? If not, we get rid of the last digit. Are these two equal? If not, get rid of the last digit. Are these two equal? They are, so we return true. But then let's say this is a 5 instead of a 6. They're not equal, so we can get rid of the last digit. And now we're at the case where this number, oh wow, it just makes a circle. It is less than this guy, which means we can automatically return false, which will be our base case. So let's do this. So our base case will be if if A is less than B, just return false.
Could we also, and this is kind of like a suggestion, saying that if A is less than or equal to B, or no, actually, let me double check that for just to clarify. Like, if say A is less than or equal to 0, or B is less than or equal to 0, return false as a for the recurrence.
If A is less than or equal to 0 or B is less than or equal to 0. So let's see this. And you want to return false, right? Ye
Yeah, does that also work, or
let me think.
because I'm out of curiosity.
Actually, yeah, this should be the other way around, first of all. Uh, will this work? Yes, but well, first of all, we know that the two integer parameters are both positive. Um, so I mean, A could be 0, so I guess this could be true. Um,
Mm,
but we don't really need this case because A is never changing in a recursive call.
okay.
Uh, and then we have this B is less than or equal to 0, which is basically the same as B is less than or equal to A, because as we chop off the last digit by divided by 10, this will eventually equal to 0. At the same time, if we have A is, let's say 2, and B is 747, and we chop off, this eventually becomes 0. So they're basically the same thing because 0 is less than 2, and as well as B is less than or equal to 0. But this case is better in the event where, what the, in the event where, let's say A could be like a higher number and then B is something like this. Using the first if statement, when we're chopping off this guy, it can already return false. Whereas for this statement, we have to keep chopping until it's 0. So that's more function calls. Will we have problems in multiple base cases? Um, it's possible. I'm not sure. Why would you have that? I doubt it for 212. I mean, when would that even happen? I'm not even sure. Yeah, so not sure when you would have multiple base cases. But to complete this, we can just now do return if A equals B is equal to B, return true. Else we can return start with A, B divided by 10. 7. True, true, false. Let's try that example. Okay, it's good. But if this was 7, it should be false, which is good. Okay, so let's ask question. Moving on. If there's no questions. Let's see, right, first function called display. The function hasn't. Okay, there's a lot of number manipulation. Is there like these all number manipulation? It's kind of Jesus. Uh, with this one, there's an array. Regular function called sums that replace each entry in the array of integers by the sum of that entry and all earlier entries in the original input array. Let's see, so we're given this 4 plus 4, 1 plus 8. Okay. So for this problem, if we're given 3, 1, 4, 1, which is 1, 5, 9, which is pi, but yeah. So we return the output is 3. The next number is 3 plus 1, which is 4. And then it's 4 plus 3 plus 1, which is 8. And then it's 1 plus 4 plus 1 plus 3, which is 9. And then we just add 5, which is 14. Add 9, 23. So writing this recursively, um, hmm. So Let's see. We're gonna need an index counter. So for our parameters, we need some index counter. What else do we need? We need an input array as well. And if you notice, these numbers are equal, but then for the second element, we're adding one to the element before. So we're taking our current element and just adding one to before. Same for this guy. We're adding 4 to the one before, which is 8. We're adding 1 to the one before, which is 9, and the same, and it continues. So what we can do is start off with our uh, array. I'll just modify to in place, right? Okay, so it's going to be return void. Let's name it. So we take an array, and then we also have our index. Our base case. Actually, let's do the base case last. So as I said previously, we're taking the current index, x, and then we're just adding, we're setting the the value at x to be x equals x plus x minus 1. Just confirm. So x is 1, x plus x minus 1 is 4. Yeah, okay, so we can do array at x equals array at is it x 1 plus 3. Okay. So we need a recursive call. Our recursive call will be, let's see. So we're going to move to the right of the array. So once we reach the end, so our index has to x, if x is greater than array.length or equal to, which means we're out of bounds. If it's out of bounds, then we can do array at x equals, actually, we're still going to do this, actually. So return, that a recursive call would be just sums at array and x plus 1. But now the issue is initializing the first value, which is actually not, is that a problem? Because we can do fx is equal to 0. Wait, what are the parameters? Did I give it random parameters? Sums x6. Oh, so it's giving us index of 6 to start. 2, 3, 4, 5, 6. Okay, so if it's giving us 6, that means we're starting from the end, and we're actually going left. Let's just say it starts at 0. Because, yeah. Uh, it starts at 0. We need to do if x. If it starts at 0, this will create an exception, because 0 minus 1, -1, we can't do that. So we can do if x extra protection, we can just do turn and then call array at x at 1. Did that work? Oh yeah, let's see. So when we reach this point, we know that x has to be 1 or greater. X at 1 equals 1 plus array at x minus 1. Okay, let's just try it. What could go wrong? 3, 4, 8, 9, 14. Okay. Two base cases. Yeah, so some previous person asked for a question with two base cases. You could make an argument this is two base cases with two returns, but this is more like error checking. If anything, ideally, you would just have something like this instead. Uh, and just never call. So this would be like in some private separate class, and then you are only exposed to this function. So when you call that, it'll always start at 0. Actually, no, let's start at 1. My bad. Yeah. Any questions? These are like fucking leak code problems, bro. What is this? Yeah, and anyone with like a soul would just use a for loop, but you know, we're here to make things a little harder for us by using recursion. So if we're all good with this, can move on. It's getting a little too difficult for my liking. Okay, but let's just pick a random one. Write a virtual function called double digit that makes each digit repeat twice. Oh, okay, okay, okay. That's actually interesting. So we have 9 becomes 9, 9, 8, 1 becomes 8, 8, 1, 1, 2, 4, 3, 2, 2, 4, 4, 3, 3. See, we're good on time. Okay, we have an hour left. Oy, okay. So, just bang this out and double digit. So our base case. Well, actually, what even happens in this function? let's say we start with a 244. Remember that we're going to do some sort of uh, divide by 10 mod 10 in order to shrink our input until we reach a base case, while at the same time getting our last digit. So if we get our last digit, we do mod 10. For this input, we have a 4. We somehow want to make it 4, 4, and then pass this down, do the same thing. We take 4, 4, pass the 2 down, 2, 2, and then we hit a base case. So we return back up to 2, append it with 4, 4, append that with 4, 4, and that would be 2, 2, 4,
I
4,
mean, you can think of the
4,
function
4.
saying that if it's less than or equal to zero, right? If int x is equal to less than or equal to zero, is that also a good base case?
Yeah, so I suppose that whenever you're doing divide by 10, you could always have the base case of x less than or equal to 0. Because for recursion, we have our base case and then our input parameter, which we are shrinking down to reach the base case in our recursive call. So yeah, we can do x less than or equal to 10, but then what do we return, right? Because we're returning a number. I guess we could return 0. Um, we can return 0. Uh, yes, because we're not dealing with strings. So when we have 2, 2 and 4, 4, the way we're basically adding the two numbers. So when we reach our base case over here, we have 0. 0 plus 2, 2 is 2, 0, 0, which is just 2, 2, which is why we can return 0. Now for our recursive call, we always want to shrink the parameter. And now we want to do some math in order to combine the two numbers. Um,
Can suggestion of using a standard for loop because I don't know Steinberg that we just said make your life easier by using a standard for loop.
so, oh, you want to use a for loop instead of recursion, is what you're saying?
Yeah, I mean, I feel like it's like it's much more easier to have to go to the for. I remember more of using the for loop than it is having to remember the recursion a lot instead of having to make my life harder.
Yeah, so like practically speaking, you should rarely ever use recursion and just stick to iteration. But um, for all these problems, you're meant to write a recursive function in order to get some practice doing that, as well as for the midterm, the professor wants us to go over writing or creating recursive functions. So that will probably be on your midterm. So to continue with this, oh, question, thought a function that would have two base cases, Fibonacci. If x equals 0, return 0, x equals 1, return 1. Yes. Yeah. I think. Yeah, so I guess you would have two base cases in the event where uh, if you have a function with some parameter, and that parameter can be it can match a base case, of course. Base case number 1. Let me think here. Actually, it could be like for Fibonacci, it should be less than equal to 0. For just error checking, return 0. And then if x is equal to 1, return 1. So question is like, why would you have two base cases? You would have two base cases if one, you're doing some error checking, I suppose. So you don't want to return Fibonacci with like -1. Like this doesn't make any sense. Um, so that's why you have the less than or equal to 0, as well as if you pass in 0, since Fibonacci is doing should it be 0? Shouldn't it be 1? Because it's what, 5 times 4 times 3 times 2 times 1. You can't times 0, or it negates everything. I assume, and 0 factorial. Wait, no, it's Fibonacci. I'm not sorry. It's not factorial. Yikes. Fibonacci is what? 3 equals, is it like 1, 2, 3, 5, 7. Just confirm. Okay, so you're increasing. I guess I don't have a good answer for why would you ever have two base cases. It's just a special case, really. I can't really explain that. When you have like multiple inputs, uh, parameters that can take on, the function, the recursive function can get multiple inputs. So for like 0 or 1, in which case you want to return two different values. And you can't turn 1 to 0. So if you could return 1 to, if you could transform 1 into 0, then you can just get rid of that base case with the number 1, but you can't. So that's why you have two base cases, if that makes any sense. But anyways, um, for this question, so we want to take a number. So we have 4, 4, right? And the number 2, 4, 4. We want to take the last number and turn it into 4, 4. To do that, we can just do double lasts. So we have x mod 10. So that's our 4. To make it 44, you can just do times 10. So it becomes 40, and then just add it with x mod 10. So that becomes 4, 4. And then for this, we want to add it to, let's say, 2, 4. This becomes 4, 4. This becomes 2, 2. So this will somehow return 2, 2, theoretically. And we want to add it to 4, 4 to create 2, 4, 4. So we can just multiply by 100. So this becomes 2, 0, 0, 2, 2, 0, 0. And then we just add the double last. Is the same as times 11. What is the same as times 11? Uh, this part? 4 times 11. Oh, I see what you're saying. Um, I suppose you can do that actually. Yeah. What, 9? Yeah. I guess you could times 11 instead. Yeah, but anyways, so let's see. Double last times 100 plus 44. So 2, 2, 0, 0 plus 44. Does this even work? Let's see. Where are we? 9. 99811 224433 224444. So yeah, this is the answer. There goes the page. Any questions? Let me try to find an answer. Let me try to find some questions that don't involve uh just mod 10 times 10 stuff. Uh, a string problem? Yeah, yeah, sure. So let me try to find one. Reverse a string. Okay, okay. So reversing a string, let's say if we're given a string x, that should be x. If we're given a string xy, it should be yx. Just toss in a one. Yeah, two, three, just y, three, two, one. So reversing a string, and of course it's a string, so we can pass a null. If it's null, I guess we return null. So our base case would be if we have an empty string. So remember that, let's see. For recursion in general, you have your parameter, you have your base case, yada yada, and then you have some recursive call. This recursive call, you're going to usually shrink x, and then maybe do some operation as well. So we need to shrink x. Um, so when we're shrinking x, our base case would be if x is empty, or the length is 1. So if we shrunk it enough, we can return s or x. Now, of course, we passed a null, so I guess you could make the argument this is another base case. Um, two base cases, more like an error checking type thing. Just let's combine these two. Actually, it's fine. So that's our base case, and now we want to reverse a string. So for this example, we want to get the last character, x. If we do x.char at, no, we can't take the last. Let me see. Recursive call plus an operation. So we can do reverse. So we're putting x to the last, to the end. So we can add 0 to the end, and then reverse x substring 1. So if we see if this works, that matches up. And actually, let's just do this instead of just yapping. Let's actually see what happens. So if we're stepping into this function, we see we're given our initial value of x123y. We're passing through it. And now we're reversing the substring of 1, which is 123y. Of course, we're going to append it at the end. So now we're going to pass in 123y, follow through. So now this is 1. Before it was x, now it's 1. It'll be 2, it'll be 3, it'll be y. So let's just go through it. 2, 3, 2, 3. Shit, we bubbled up. Actually, that was way too confusing. Let's just do this. 1, 2, 3. So this was all false. So now we're returning function substring 1, which is 1, 2, 3y, and we're adding the first character, which was x. So now we're into this function. We passed in 1, 2, 3. We passed in 2, 3y. And then we added the first character, which was 1. Then we passed in 3y. First character was 2. Then we passed in y. And at this point, for this, it'll return y, because that reaches this base case. The length is 1. So when we're bubbling back up, this becomes y3, which is the result. Let me just this color. Result for this guy. So this becomes y32. That's the result of this function, this whole thing. That becomes y321. This is this whole thing, which is y321x. And this is the answer. See if I can find another string problem. There's no questions. Okay. We can do is palindrome. So just get rid of that. So this question we want to is palindrome. It's a drone, drome, string X. And remember, a palindrome is a string where it's basically symmetric. We want to do this recursively. We want to return true if it is a palindrome and return false if it's not. So if we have race ka, this is different, so we return false. Our base case, of course, as you can see, we're going to have these, we're going to check the two ends of a string, and then we're going to shrink the string. Then we check these two guys, shrink it, check these two until the base case where the string is of length, a single length. Or we have the case where it could be like this. So our string is empty as well. Let's code that up. So once again, our base case equals length 1 or empty. So two base cases if you want to think of it like that. And then our recursive call is shrinking the string plus our operation, which is checking the ends. So Boolean is palindrome. So we start off the base case, x.length is empty, or x, actually the length is 0 or 1, so less than or equal to 1. So make that one base case. We return true. We return true because let's say it's empty. I guess that's a palindrome. If it's just one character, that is a palindrome. So we return true. Now for the recursive call, we want to shrink the string and an operation. And because we're not doing like some append operation or like number operation, we can do something, we can separate the operation from the recursive call. So in this case, the operation would be like before the recursive call. So 1, we do this, and then we do that, this, that, this. So if checking the ends, so we're up to this part, if x dot char at 0 is equal to x dot char at x dot length minus 1. So if they're not equal, you want to return false. In the case that they are equal, we want to return uh, the recursive call with a shrunken input, the shrunken string, which is just x dot substring 1 to x dot length minus 2, minus 1, minus 2, minus 1. Let's try that. So this palindrome, let's do x, empty string, xx, xxx, let's do xy. Let's see if this works. So true, 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 false, true. Yes. Let's try stick this guy in there. That should be true, which it is. So that's the answer. Questions? And of course, x could be null. If it's null, we can return either or. We can just say it's false. Up to you. Do you want to define null as? Does this work? And we just copy and paste that. Plus one, z minus one. Does that work, you say? Y equals zero, z equals the last index. If they're equal, yeah. Um, it's in the base case. It's a little incomplete. Um, actually, okay, yeah, I see. So then you would return false here, right? Instead, let's just do string. Well, first of all, okay, X is your string, but then you're passing in that. So just to be clear, someone asked if this was okay. I'm just gonna fix it up real quick. This is actually fine. But for Y and Z, we need to actually physically make that as a parameter. Since instead of shrinking the string, we're going to shrink our X and Z. X and Z being the pointers to the where we are right now in the string. So we're going to shrink that instead of shrinking the string itself. So to Y, Z, we got to pass in X. And if you do this, then you need a helper function where you start off like so. What is, oh, base case though. Base case from the base case. The base case would be, since we have two pointers, it would be y is greater than z. Because we gotta make sure this doesn't go out of bounds. And we start at the ends. We're slowly shrinking towards the middle. In this scenario, that would return false. I'm talking about this scenario then. So right here, then this becomes together. Then that's true, so this will run. So now we have opposite pointers. So yeah, so y is greater than 0. Return true. Let's see if that works. 4 trues, 1 false, 2 trues. Yeah, so this is an alternative method, but that it requires a helper function to initialize the variables with. It's like we're doing LeetCode, bro. What is 2 pointers? Hello? Uh, next question, if there's no questions, we can do counting occurrences of a character. Um, int count occurrences. So we're giving a string x, and we need to return the number of times character C appears. Occurrences. So if we're doing what? Bunch of letters. Actually, let's A. And we'll check letter A. This should return 3. Why is it not? Oh, yeah, of course. If we're doing this, it should return 0. Okay. So doing this recursively, hmm. We could do two ways. Either we can have a pointer or not. So let's see, we're given for AAA, we want to try and check A, the base case, of course. Let's say you're only given this function and you have to fill it out. So you're given X and C. Our base case would be, let's see, for the recursive call, we're going to be shrinking the input. So this becomes AA, this becomes A until there's nothing left. So we're going to be shrinking X. And then that leads into the base case where X is empty. So X dot length X equals empty string. And then we could do or null in case that ever gets returned. And of course, our operation plus an operation. So we do add 1 if char at 0 is equal to target, which is C, because we're counting the occurrences. So let's just start with the base case. So X is empty. Return 0 if X equals null. Return 0. And then return count occurrences substring 1. We're shrinking the input, passing in C as well. And we're adding 1 if the character, let's put this on new line, char at 0 is equal to C. We're going to add 1. Not, we add 0. So that's 3, that's 0. Maybe let's get rid of one of the A's. Nice, nice. And if this, to be clear, is a ternary operator, same thing if I can just, oops, can do this instead. Same thing. But let's be extra complex for no reason and use this. And if you wanted to use the index version, because usually if you can use an index pointer instead of substring, like resizing the string, it's more efficient. Um, so we're doing this. We can do the same thing, actually. Now our base case is based on the pointer. So to be clear, our pointer points to the current index. We're checking, is the character at the pointer equal to the target? We add 1. Move the pointer to the right, check. Move the pointer to the right, check until the pointer is out of bounds. So then our base case would be if index is greater than or equal to x dot length, return 0. Else we return x dot char at the index equal to c. And then just to match the thing above the previous implementation, we can do kept occurrences xc index plus 1. And of course, if you're doing this method, we need a helper function. Start this first index. So these should return the same thing. 320, 320, yep. So pick your poison. Uh, this is more efficient. Okay, no, any questions? Oh, we have a submission. Oh yeah, just make sure to fill out the feedback form if you want more review sessions in the future. Doesn't need to be with me. If I'm not good, it's all good. So let's see. Some person sent in this. Oh my God. If chart 0 could C, return 1 plus. Yeah, so is that the same? Uh, 1 plus substring of 1. Oh, this matches this thing up here. Okay, wait, let me just. And then that's length 0. Yeah. Chart 0 equals C. Count occurrences plus 1. Yeah. This should be C. Like, yeah, this solution is completely fine. Very nice. Okay. Let's maybe move on to binary search. Nah, no, let's not do that. Um, sum of an array. Actually, let's do leak code recursive problems. Does anyone have questions about Java in general? I fucking hate doing I leak code is it's not questionable. Okay. Yikes. Merge two sorted lists. Oh hell no, it's not this. Okay, I'll just some recursion problems on LeetCode. I doubt you'll get a anything as difficult as these. Even the easy problems are probably harder than the ones you have in class. List nodes. Okay. Let me see this guy. A student asked for list nodes. Do you want to go over like what about list nodes do you want to check out? Like like a linked list recursive problem? Actually, how about this? Why don't I just ask Mr. GPT to get some questions based on this? Right, this problems. The important idea is we should know for problems that could show up. Um, Important things you should know about linked list for practice problems that could show up. Hmm. I'm not completely sure. I mean, the professor said he didn't really have any specific questions for this review session. Make up similar questions to the, the similar to this. Tutor should go over writing recursive methods, as that will appear on the exam as well. So, I mean, if y'all are comfortable with all this, should be good, I think. For the exam, will it get harder than writing methods for linked list? I don't think so. He might ask you a recursive problem with using linked lists, which is like, I don't know about that. Would you even use recursion on linked lists? Like, let me think of what question he could ask you. Majority of questions on the exam are focused on linked list and recursion. I would say yes, based on what he gave us. He told us two things. Go over this exam or make questions similar to this practice exam or whatever this is, homework, as well as go over questions regarding recursion, writing recursive methods. So recursive methods, linked list, I assume that's what the test is going to be about. Actually, a question we can do is count occurrences given a linked list. So let me pull this up. So this is all this. Now we want to write count occurrences using a linked list instead of a string. Yes, the recording should be posted by before the exam date. Let's get to that. Okay. This should be static. Uh, I guess you could do that. Okay, so let's write count occurrences using recursion. So we're going to only be given a char character. We need to recursively go through all the nodes and then at the same time return the occurrences. So for example, let's say we have something like this where the data is A, B, C, B. We want the occurrences of B. There are two B's, so we should return two. Writing this recursively, I mean, we know how to iterate through the linked list with the while loop, I hope. But doing it recursively, same process, our base case, uh, and we're shrinking the input. So our uh, base case, and then the recursive call. Oops. Recursive call, base case. So in order to determine the base case, we need to determine the recursive call first. And so the recursive call is some form of shrinking the input. Uh, so actually this would be, we need to pass in a node actually. So we pass in a node, then our recursive call shrinks the input, which is equivalent to passing on the next node. So our original, our recursive call, another recursive call. So we're slowly shrinking the input until we reach our base case where this guy points to null. So node dot next equals null. Recursive call equals we pass in node dot next as well as C. So handling our base case, if node dot next is null, turn 0. Node could be null. Can it be null? What is our add function? Head is initialized to that, so it should not be null. Then our recursive call, we want to check, we want to return count occurrences, node.next, C, and then the same ternary thing we did before, node.data. This should be actually E then, if we're using generics. And we have to use now dot equals instead of equals equals. Uh, target. You could use equals equals if you want to like compare references, but this is usually more appropriate. And then, of course, we want a helper function since we don't want to. This will always start at the head node, so we want to return count occurrences, head, and target. And then with helper functions, we want to usually private the actual recursive call. So now we can do uh, new myLink list. Let's do, that's good. Let's add some guys. Let's do this. Let's print out the original list and print out list.count occurrences of the character A. Okay, let's do this. Please work. Okay. Node is null. I was afraid that was gonna happen. Why is it null? Node.data is null. This guy. Wait, so it should be what, head done next? Yeah. Oh, 0. Okay. Because it's a character. Yes. 2, 1, 2. Very nice. And then just to clarify, the first error, we need to pass in head.next because for this implementation, we have a dummy node at the start. So this is just null. So we want to start the recursive call at this point for this section. That's why you pass in head.next. We want to start here, not here. And then if we pass in a character, when we're comparing a character to a string using dot equals, it's going to return false because a character is not equal to a string. So we need to pass in a string instead. And then we could do, let's try a different type, maybe numbers. Let's do 1, 2, 3. That should work. Yeah, 2. Make sure just should be 3. That's good. And then what if we make it a double instead? Because yeah, let's see. It should return 2. Yes. What about a float? 1. Okay. And then maybe instead of counting occurrences, oh, okay, never mind. It's gonna say like if it contains 1, 2, 3, but then you need a custom comparator. But this will suffice for now. Any questions? Are we all good? Let's see, it's 10 minutes left. Also fill out don't forget to fill out the attendance form and feedback form in order to further fund these review sessions.
Thank you very much. I just wanted to say thank you, especially for the this one that we just did, the linked list recursion. That was really interesting.
You're welcome, man.
Yeah.
Appreciate that.
Mhm.
So it was typed in earlier and asked about the recording will be posted as possible as soon as possible, to, likely tomorrow morning, right?
Ideally, yes.
Hopefully by tomorrow morning,
Hopefully.
because I
I don't know.
really want to. I missed out on a lot. I'm sorry because I came in like an hour late. Um,
It's all good. Yeah, we'll try to get that recording posted as soon as possible in the Learning Commons YouTube channel.
All right. Thank you so much.
No problem. There's no questions. I mean, there's only 10 minutes left. We could do something maybe a little experimental. Um, so like, what if you wanted to do instead of count occurrences, you wanted to do does the number contain one, two, three? So like, if I have the number three, one, two, three, four, it contains one, two, three. How the heck would I do that, right? And then, of course, this linked list, we're using object right now, but ideally it should be like integer or something, like integer or something. Oh, my bad. That's, of course. Then, like, what if it's a string as well? Like, then I want to see if the string contains one, two, three, or something like that. In that case, you would have to write some spooky code. You would have to have a comparator. Let's do instead of a predicate, import of type E, and then uh, condition. So our condition is whatever we want to pass in here. So, so in this example, we're checking if no.data equals targets, but this should be yeah. We want to like have a custom condition based on what we pass up here. So we want to check. Let's just say, for simplicity's sake, just return. Uh, I guess we don't even need a target. Do we need a target? Nah. Contains. So should still equals 2, 3. Count occurrences. This condition plus condition. So now we're testing condition on our data. So no.data. Of course, this becomes our Boolean. So ternary. So this is functionally equivalent to what we just did before. We're checking if the number of occurrences of 1, 2, 3. So this should return 1. If I add another 1, 2, if I add two more, it should return 3. But let's say we're given strings instead. So these are all strings. Now we want to check, does it contain 1, 2, 3 instead? So what we can do is do x dot contains 1, 2, 3. So we're not limited to counting the occurrence. Just froze. Okay, it does that sometimes. We're not limited to counting the checking if data equals some target value, we can actually check if the data matches some condition or predicate, contains, it starts with, is a divisible by 10 or something like that. Like, so we can do like x mod 10 equals 0, and then this should be integer. So we're not limited to checking if the data equals something. We can do anything we want if we pass in a predicate. And this predicate is being called over here, so dot test. So we're taking whatever node.data, we're testing it. So then it calls this lambda function. So this becomes node.data, and we're checking if node.data mod 10 equals 0. If that's true, we just return 1 to the count. So this is like dynamic in a sense. We're not, if we pass in target, then we do target dot equals node.data, we're limited to target being, we're checking target equals node.data instead of anything we want, really. Yeah. So we got like 4 minutes left. I think that'll wrap up this review session. Any last thoughts or questions? Feel free to leave them down. Other than that, y'all are free to go.
Thanks a lot. But we do have the just in case if I ever lose the PDF file for the questions that Oren kind of Professor Steinberg pretty much gave us. It will be posted on QC Code for All, right? So if we ever lose it or whatnot.
Yeah, we can make sure to post it there as well.
Okay, thank you. Because I already have the PDF on file. Just wanted to like make sure if I ever in case lose it. That's why.
Yeah, no worries.
All right, thanks, guys. Have a good night.
Good
Yeah,
night,
have a good
y'all.
night.
Thank you for the review. Have a good night.